Welcome to week 3. So today we will first review the homework, and then we will talk about data structures in C++. So today probably just a part 1, and then we'll continue this discussion next week. We will go through some those building data structure, arrays, stack, queues, and string and dynamic arrays, and then we'll talk about the function overloading in C++. So let's look at last week's homework. So there are 3 problems. The first problem is just a 3 character of a string, and then checking see whether those A, B, and C, the 3 character, whether they are in the right order, and then whether you can pick 2 characters and then swap them to make them in the right order. So there are multiple ways to do this. Okay. Well, first of all, in terms of the process for any of those problems, so we need to read the inputs, the 3 characters, and then you just need to consider what are the situation could be yes, or what are the situation would be no. Okay. When there are, you can consider they are in the 3 situation, right? When all 3 cards already in the right order, you do nothing, then it's a yes. If there are 2 cards in the wrong position and then 1 card in the right position, then you just swap those 2 cards in the wrong position, so it's a yes, right? And you cannot have 2 cards in the right position, just 1 card in the wrong position, right? That could never happen because the 3 cards, you cannot have 2 cards in the right position. The 3rd card has to be in the right position. So it's only those 3. So then either 2 cards in the wrong position or 3 cards in the wrong position. So those are the only 3 situations. And for this A, B, and C, so you can just find out that there are only 2 scenarios that will fall into this 3 card in the wrong position, right? So it's B or BCA. So only 2 positions. So you can check whether the input is in those 2 wrong positions, which fall into this 3rd scenario, then it's a no, and otherwise, yeah. So that's one solution. Or you could just check each of those scenarios, right? See whether they are all in the right position, then yes, or the 2, or you can do whether they are not in the 3rd scenario, then it's a yes. If it's in the 3rd scenario, then it's a no. Yeah. So in the logic that said in the 3rd, checking the 3rd scenario, right? All 3. So you read this string, right, into, and then you're getting each character, the 1st character, 2nd character, 3rd character. If it's not A, or B is not B, and C is not. So this is the 3rd scenario. All 3 of them are in the wrong position. Then you output a no. Then you output a yes. Right. So this is using the 3rd scenario. You just check the 3rd scenario, then say yes. You can also do just checking the first 2, see whether there is at least 2 in the correct position. Then you also output a yes, otherwise output no. So there are multiple ways to solve this. Or for the 3rd scenario, this is that you can just compare, see whether this string is fall into those two cases, right? Is with a CAB or BCA. So only those are two cases that will be a no, otherwise will be a yes. So I think for those submitted homework, I think you guys are all did it correctly. So Dominica and Kenny, you guys have not submitted homework. Okay. Any question on this problem? For problem number 2, it's just checking to reading a series of numbers and see. Right. First of all, the logic is, although is trying to find out the biggest product possible when you're trying to add 1 to the number. So if you go through an example, you can quickly find out the number you need to add is the minimum number, right? So then add to the minimum number of the series that will make the product the biggest. So how do you find out the minimum number of those numbers you're going to read? And one thing you need to be careful is that this series is including 0. So between 0 and 9. So, and there is no guarantee that you only have 1 0. You could have a multiple 0 as well, right? So you make sure that if it is there multiple 0, then the product is obviously is 0. So you need to handle that situation as well. So in terms of the process, right? You first find out this logic, find out what's the smallest number, so that you set add 1 to make the product maximum. Then you just need to handle the give you how many cases in the test cases you need to loop through that test cases, and for each test case, then read each number, and then so you can save to a vector, or there could be a case that you don't need to save the vector, just keep track the product. That could be a case as well. So you want to save the memory, then you don't need to save to a vector. Then find the minimum smallest number and then calculate the product. Okay. So the example, so first of all, make sure that the product you use a long, because when you get into a situation, you don't know how many product, right? The multiply can be out of range of integer case, which is 32-bit integer. It could be the product. If you had a lot of product, it could be out. So make sure you use the long of the product. So this is a scenario we store those number in a vector. Okay? So you first read how many tests. For each test, you go through this loop, right? So this first loop is going through each test. Then within each test, you read how many numbers. The number is n, and then you put since each number, the digit is between 0 and 9. So you can assign the minimum to be 9 start with, and then the position of the minimum number is start from 0. Then you go through each number, you read this number, you push back to this array, to this vector array, and you check whether this number is less than this, you're starting with minimum is 9. If it's less than, then you set this minimum to this number, and then set this minimum number position to this J, this index, right? So you keep track that. This is where you read those sequence saved in the array. And then when you're done, so this position that you keep track, that's at the minimum. You just add 1, so you increment add 1. Then you calculate the product. Calculate the product. Your product starting from is 1, then just multiply each number, and then you output it. So this is a very safe case, regardless of whether it has a multiple 0 or not. This is still correct, right? So if it has a multiple 0, the minimum you calculate is 0, and then you increase that number to be 1. Then when you do the product, one of them could still be 0. One of them is 0, then the product, then the output is 0. Right. So this is much safer. You could, right, in this product, put this accumulation of the product inside this loop. But then inside this loop, when you do the product, then you have to divide the product when you find out the minimum, divide the product by the number, and then multiply the product, the minimum number at 1. So you just need to keep track that that's also possible. Okay. Any question on this problem? Right. In terms of complexity, what's this problem's complexity? So this is a number test. So you consider this as an n, or consider this as an m, and then inside each test, this is m. So the complexity is, well, there is a 2 loop, right? Inside this loop is O2n, but O2n we said is the same as On. So this inside is On. Then this outside loop, considered the number of tests, is an m. So the overall complexity is O m times n, right? Number of tests times the number of numbers. Okay. Okay, the last problem, this problem probably is a little more complicated. Okay, so you need to keep track of a list of people, and then you have multiple round of gift giving, and in each round, who is given money and who is receiving money. So you need to keep track. If the person that gave out money, you need to subtract the money and hand it out. And for those receiving money, then you need to increase the money the person received. Okay. So in terms of just a typical process, right, doing this analysis before you write your code, right? How do you read the input? Okay. So the input, there is a list of people, and then for each round, then you need to read who is giving the gift, right? Gift giver, and then we have the gift giver's name, amount to give, and then the number of people to give, and then a list of people to receive the gift. So that make sure you can handle those inputs. Then in terms of the logic, you start with, right, you basically need to keep track each person's name and their balance. You start everyone's balance is 0, then you go through each round of gift giving. Right? At each round, just deduct the total amount the gift giver that handed out the total amount of money, and then add those for each person that received money, then add their money to their balance. Okay. So for this the problem, since we need to keep track the name and balance, so this is a data structure. If for those of you who have learned a data structure called map in C++, that's where you hide the name and the value. So you can do it using a map. And then for those who learn Java, this will be a hash map type of data structure. And then for those who learn Python, this is more of dictionary type of data structure, right? You have a key and value. Basically, you're mapping the key as the person's name, and then the value is the balance. So if you don't use this map type of data structure, you can use two arrays, right? Two array. One is the list of names, another is a list of balances for each. As long as you line them up, right? The first array of those names corresponding to the first balance as you line them up, and then you just need to go through each search. When you're given a name, you go through the name array, find out the index of the given name, then use the index to get the index for the balance. Okay, so I'm going to show you the solution using map. So this is a map data structure, and you do an include map. This is a header. Then the map is a string and integer. So this is a mapping of a string to an integer, and then call this map as a variable name called balance map. Okay. So balance map, you so first we read the name, right? So the number of people, remember the first line is the number of people. We read it into from number of people. Then the next, so this is n people, then we go through this n people or loop to read the list of the name, right? For each name, we save into this name variable. Then we also have an array, this vectors array, store this list of name. The reason we also store this is so that we put them in the correct order. One issue with this map, right? When you add it, it doesn't remember the order you added. The order is a sorted order. It's alphabetically sorted order. So this balance when we add a name, right? The person, the name say start with A will be first. If even though we add the person start with Z the first, but then that person's name start with Z still be last. So when you using a map structure, you need to be careful, right? In terms of how you want to arrange the order. So if you want to keep track exactly order, right? You can use the name, put it into a vector. Then for each name, you go through this balance map that will be in the same order in this name. So the way to build this map structure, you put in this key as a name and then the value. So this the balance for this person's name is 0. Right? This is very similar to Java in the hash map and then Python dictionary. Right? Is set the key, the value. So this is to do the initialization. Then for each run, right? So we go through this loop for there are n people. That means there's n people run doing the gift giving for each run. You read the first name is the person giving out gifts, right? And then the total amount the person will give, and then the number of gifts, number of people will receive the gift. Then you check whether this number of people receive gift is greater than 0, then you go through this. Otherwise, if this is 0 and the number of people give a gift also 0, then you don't need to go through this update, right? And you figure out for each person that receives a gift, what's the amount that, right, divide this total amount by this number of gifts, right? So this is an integer. When you're doing all those numbers, they are all integer. When you do this division, then it's automatically giving out integer. So if there is a remainder, right, you can keep track this remainder using this percentage remainder operation. So this is the amount, right? That's the total amount that they say that I want to give out, but it's not necessarily divide exactly, right? So we do this integer division, and then if there is a remainder, we subtract the remainder. So that's the net amount this person that handed out, right? We subtract from this is a gift to giver, this name. Remember the first, we read this name now is the gift giver's name. So we subtract the net amount this person gives. So this is important, right? Even though indicate the amount, it's not necessarily giving out exactly that amount. It's only giving out the integer divisions among remainder. Still, the person still have that amount. And then for each person that received the gift, so we go through this list. We read the person's gives the name. Then we add this gift, which we calculate here, right? Increase that amount. Then just go through this loop for every giving run. Then we are done. Then we output. So this is keep track the list, right? That's why we said you have the order. This is names. Is this a vector, right? We build this vector according to exactly the order we read first. So this for loop get exactly the name, and this is person's name, and that's the balance. So you see this balance map, this map data structure. Once you have this, you don't need to do any array search, right? You given this name, and then you pass the name here. It's automatically get the value. So this is the key, and then you pass this key as an index to this map. Then you get a value. Any questions on this problem? So I don't expect anyone to use this map data structure, right? So I thought, think Alan, Joel, and Kriti, you all solved this problem correctly. Kriti, do you mind if I share your solution with the class?
Yeah, that's okay.
Okay. Okay, let me share your solution. Okay. So Kriti create this two array, right? One is keep track those name, and one keep track the balance, right? So this is perfectly fine using two array. And then you first read this list of person's name into this list, into this names. Okay, so he's using a string vector, and which so it's very similar to what's the one that I use vector string. Okay. That set the initial balance for everyone to 0, and then for each run, it's reading this as as the person giving out the gift, and then S2 is the person received the gift, right? Then within that, you just need to go through this names array, find out the index of that J. So just for each of those, so this is where without the map, you need to go through this loop. And go through this loop, and you search, see whether this a name, which index it is. All right, if the name is the same, then you update the balance, and then also increment the amount given out, and then you can stop here. You don't need to go further doing the search once you find out, and just go through for each receiver, go through this update. Then when it's done, also need to update the person that giving out the gift. So this is the part, find out the persons that giving out the gift. So this S is the person giving out the gift. Then find out that index, and then this is the amount that giving out, you subtract that, and then you break here. Right, then you output the name and the balance. So any questions on this problem? All right, let's learn today's topic, data structures, right? So what is a data structure? A data structure, when in the computer science, is dealing with data storage, right? And it's not just about storing the data, how you store the data, but also concern how you can access the data and then update the data and then efficiently. So different type of data structure have a different access pattern, and some data structure can access very quickly, like the problem number 2 you have seen, right? When you're using a map data structure, then you can, given a name, which is a key, you can get that index just with one code. You don't need to do a search. Versus if you use an array, then you have to go through an array search for doing a linear search. So that's the different access pattern. So obviously using a map to access a value is much quicker than using searching linearly all the elements through an array. So in general, right, data structure is not just about organizing the data, but also about processing the data, how to retrieve an element, right? And how to add an element, how to modify an value of the element, and then how to delete an element, and how to traverse all elements. So when we say data structure, automatically indicate you have a sequence of elements of the same data type, how you want to store it. So if it's just a single element, then it's just have one address, right? There is no searching needed or no something, right? Which is when you have a multiple of them, you put them together, that's where you need to concern, where can I find the element that I need? And if I need to insert in the middle, can I do that or not without impacting existing elements, right? And if I need to delete one in the middle, but I don't want to leave a blank space in there that made the data more efficiently. Whether I need to move other elements or not. And so there are a lot of questions related how you organize a sequence of data elements with the same data type efficiently. And the reason we are concerned about data structure because in every computer program and the efficiency of the computer program or the algorithm, they are always associated with the data structure. So depends on what type of operation that you want with the data, then you want to design the data structure to feed into your data access pattern, and then the associated algorithm to access the data efficiently. So data structure and algorithm always go hand in hand together. Just in general, if we look at the classification of data structure, so this is not just in C++, but also in other languages as well. We can first divide the data structure into what's called a linear data structure or nonlinear data structure. Linear data structure are those data that you arrange them linearly. It could be memory. They just allocate one after another. Yeah. So if it's static means when you allocate the memory, you know how many elements you need to allocate the memory. So you can allocate memory in advance exactly to accommodate all the elements. So that's a static array. Static array, when you declare a static array, you said, so give me 10 elements of all integers, right? So you need to say how many elements and then what's the data type, right? Or give me 100 doubles. So that's for each double, when you allocate memory, you know how many bytes you need, and then how many elements you need. So you allocate just a total number of elements, multiply the number of bytes for each element. Right? That's the linear memory allocation, consecutively allocate the memory for this type of data structure. Versus a dynamic data structure, dynamic, that means that it can change at runtime. So it's you start with some initial number of elements, then at runtime, when you run the program, you could add another element or delete another element, right? It can grow. Versus static, you cannot grow, right? Once you allocate it, then you are done. Until you destroy the memory allocation, you cannot do anything with that static. But with the dynamic, everything is a dynamic. That means the address, when you allocate, they could be consecutive, right, next to each other. But then as you do runtime, it could be adding another element not in the same neighborhood of the memory address. So when it's in dynamic, they are still linear, but the memory address may not be next to each other, each element. Versus this is a nonlinear data structure. Nonlinear is think about that more as they are not necessarily each one that have the same memory that they needed. Like in the tree data structure, you start from a root, then you can go to the first branch, and then you can go to the second branch, then left and right. Like in a binary tree situation, then you can go left and right. Right? So it can go as deep as you want, and then as well as whether you go left and right. So they the memory that increase is nonlinear. And another type of nonlinear data structure is a graph, right? Graph. Think about the network graph, right? You have a node, and then have a link connect two nodes. Then you could have a directed graph, which tell you the link whether it is a one way or two ways. And then those nodes and link together become a graph. So any computer language, they all have this kind of data structure, right? So in terms of C++ data structure, today we start in, probably you don't know whether we will get into the hash table or the map situation or not. Let's say we'll cover all the way to dynamic array. So array, stack, queue, set, and vector, which is a dynamic array. So array, when we talk about array in general, then if you don't have any indication, then it could be a static array. The static array is just the one that we would typically use. You define each element type and then how many elements. And then the array has an index starting from 0 all the way to n-1 index of if you allocate n number of elements of the array. And then each element has a different data type, integer or long, character, float, double, or pointer, or string, or in the future, it could be also collection, right? Could be a struct as well, or the class. And in static array, you define each element's data type, and then using a bracket, right? This bracket indicate the number of elements of that array. So and before C++ 11 standard, so those are old, I think a long time ago, you have to give a constant number. You cannot put a variable here. And since the C++ 11, which is 2011, right? C++ 11 means the standard after 2011. Then you can pull a dynamic array, put a variable instead of constant into the definition of array. Then you will become a dynamic array. So dynamic array was not possible using this kind of definition before C++ 11. So, and then back then, without C++ 11, you have to use a memory allocation. You allocate a memory and then say how many memory I want to allocate, and then assign the memory address to the variable. And that's how we become a dynamic array. That's more the typical C type of dynamic array calculation. So since now C++ 11 with this dynamic array, we don't need to learn that, the C style dynamic array situation, which is way too complicated, and then it's prone to error. So C++ 11 made this a dynamic array with a variable. You put a variable into the square bracket that made this dynamic array way easier. Okay, and once you define an array, right, if you just define this, it's uninitialized, right? There are multiple ways to initialize. Just like you initialize the variable if you use equal to one element, then it will only initialize the first element, right? So let me put this. over here. So I have this example. Okay. So you define an integer array of 5 elements. You first uninitialize. So when you uninitialize, you have to be careful. Don't trying to get the value of the uninitial array. Right? You could the value could be anything. It could be for integer. Most of the time, the compiler will initialize it to 0 for you, but that's not guaranteed. It depends on what type of compiler you use. So um, this example I just showed when you initialize, we can use this first one, using this size of to get the total memory allocated for this array. So this size of doesn't mean the doesn't mean this is 5, right? This size of is the total amount of memory allocated for this array. So if we need to get this number array, the allocate, okay, let me do this. So size of, and say, so in order to say number element of this array, then you need to, how can we get that? If we don't know this 5, we only know this array, but it's an integer array. So we can use a size of, get the total amount of memory allocated. We want to get the number of elements. Then we need to get the size of what? Int. Because each element is an integer. So each size of int will calculate the number of bytes for an integer. Okay, so this is the number of bytes for integer. This is the total number of bytes for the entire array. You do this division to give you the number of elements. And you can initialize using this braces. You use braces to assign if a 5 element. Make sure that if you want to initialize all of them, then you need to give 5 values, right? What happened if I just do this? What happened here? If I just assign braces 0 for this, what do you think, everyone? So what will happen is only assign the first element to 0, and then other elements still uninitialized, or whatever it could be initialized by the compiler. But only the first element is guaranteed to be initialized to 0. Right? Let's check, instead of 0, we assign to 1. Let's see what happened. So I have this function print integer array. It's just giving this array the number of element, this array's name. It will print out each element of the array. So if you look at this function print integer array, you get the, so using the asterisk, right? The asterisk indicate this is a address of an array, and then the size, and then we give the variable name, the string, and then how you print it out using a delimiter. So this is just say this is an integer type, this array name, and then the size equal to each value. So it decrements by 1 because we use this comma as a delimiter, right? When we get to the last element, we don't want to have a comma after last element. So we want this loop to stop the second to last instead of last. And then we print out the last element here without the comma. So this delimiter is the comma, and so that to make it nicer, so don't have the extra comma. And then the last element, then we end it with this closing braces. Okay, so if we compile this program, we and we execute this program. That's just a focus on the first two array. Let's just look at this two static array. Okay. So this said the size of array is 20. Okay. So because it's five element, and each element is 4 bytes, right? So that's why you get 20. And we printed number of elements. Okay, save it. And yeah, this output. Right here, right? Size of the array 1 is 20, but number of elements is 5. So we divide this 20 by each integer's height, which is size of int, which is 4. Then we get this 5. Okay. And you see, when this integer array is uninitialized, the compiler actually automatically initialized to 0. We said did not guarantee, right? And then the size of array we allocate to 5 as well. So it is this one, right? Then we initialize to 1. It's the only the first element initialized to 1. So other being initialized to 0 by the compiler. And how do we initialize every element to the same value? So one method, rather than like we do this list every element, like do this 1, 2, 3, 4, or if we want to initialize everything to 1, you need to repeat many times. What if we have 100? You type 100. We don't want to type that many. There is a simple way to initialize every element to the same value. So that method is using this standard templates fill function. So you use this field. If this array the first address, and then this ending address, and then what's the value that you want to fill. So this fill function is you can fill with any value. It doesn't care whether it is a double or integer, right? If it's double, you can give a double. You just give the beginning, the ending, beginning ending address, right? So uh, we for those of you that new to C++, when you define an array without anything, right? This is just an array name. This is the address, right? This is the address of that array. And then you can do addition. You add this address. Where we say earlier, static array, they allocate the memory consecutively. So you add that address to become the ending, the last element's address, right? So you can use this. So if you know the number of elements, you can use this fill function. Right? Do I have a fill integer? Okay, I don't have a fill integer. For this case, right, we can do std colon fill, right? Say array 2 and array 2 plus 5, and then we want to fill 1. So we can do this, it will be equivalent to this, right? Okay, let's take a 10-minute break. We'll come back after break. Okay, time's up. Hope everyone is back. Checking to see if one can still hear me. I have an audio issue earlier. Can everyone hear me okay? Okay, good. So let's continue. So we talk about array, and we can use this function, field function, the beginning address, the ending address, and then the value that you want to fill. Right? So just any array, beginning, the ending address, and then the value, then we'll fill all of them with that value. So if you have 100 element of this array that you want to initialize, you just one line. Right? Obviously, you can do a loop to go through each element and then assign value. Right? Just a fill function, just one line easier to assign the value. You don't need to go through a loop. Inside this field, essentially is going through the loop, the beginning address, ending address, and then assign each address to this value. Okay. Then we mentioned this variable length array, so dynamic array. That you can put a variable inside this bracket. So this is only after C++11. And then you can treat this as a number inside it. And this field, you can use a variable to calculate the address as well, right? So this code like this, you have an n. If you want to say you start from 10, you need and later on say I want to test this code for 100 elements. You just change this n to 100, and the rest of the code will work without changing the value everywhere, right? So it's just much convenient. So for an array, now you have repeatedly, if you use multiple places, then you should define a variable as the length of the array. And in addition to those standard array, there is in the STL stands for standard template library. So STL, the data structure called array, but then the actual in terms of the code is then you just use std, then colon array. That's and then in the header file you just include array. This include array will include the STL library's array library. And how does STL array different from the normal array? Okay, so you use this array, then you can define the type and the number of elements. Give the number of elements, and then this is the array's name. Then you can initialize using this double braces. The reason is using this double braces, it is an array of array. That's why they need to using the double braces. It is a container that having another wrapper around the actual array. So you use this double array to assign the initial value. And if you want to give So this double braces will assign the value for every element of this, right? Not equal, right? You don't use an equal, just using this double braces immediately after this array variable name. Or you use this equal style, then you list each element. This double braces is only immediately after the array definition without the equal. So using either two ways to do the initialization. Or you can also do the fill. But fill, you need to be careful, is not using the array itself. You need to use the data. Don't have an example to use a fill on the STD array. So, so this is a use the STL array, right? So we define, so we can, since we using naming standard, so we are using namespace STD, so we can get rid of this STD : prefix, right? So you can get rid of that. It will be the same, but we want to keep this when doing a definition. Just make sure that this name is coming from the STD, it's a library, so that just in case you have a name conflict, or you also name this array as ARRAY, then it will be okay. This is just the name without under this STD library. And so you define this type and the element, and then initialize all of the element to 0. So you see using this STD array, there is a nice way to initialize every element to this way. Right? If we use a fill function, let's try using a fill function. Then, okay, it's here. So when you use the fill function, you need to get this function called begin function and end function that will give you the address of the beginning of the array, the address of ending. So you cannot do like the one we use the static array. You cannot, like if you define this ARR9 using this STD array, you cannot do this. Right? This will give you an error. So you cannot say, even though you know the 10 elements, I do plus 10. Both give you a problem, right? Because this ARR9 is not pointing to an integer array. So if you want to do that, you need to do what's this data. So this dot data is return the address will be the same as using this begin when you or you use this data, then plus this will be the address ending the beginning address, or just it has this begin and end function. Just use a begin and end function to get the beginning address and then ending address. But in terms of like you can reference to this like a normal array. This will give you the first element, right? And if it's the one that we have a 10 element, right? So the 9 will give you the last element. So you can continue to do this. Right? Just this is a different. right? This is not the address of the memory being allocated anymore, right? Because it has a wrapper around it. So you need to use the begin to get the address or use the data. Okay. Hey, so those are probably um, two common type of ways to use a static array, and then we'll go to the dynamic array using the STL vector later on. And then also a string is another type of array only for storing a list of characters, right? String it's also considered to be a dynamic array. And we'll come back to string and vector later. But then another type of linear array is a linear data structure is called stack. Right? Stack is different from the array. Is like just like a basket. You put in some item. The basket you can only put the item through the top of the basket, and you get the item out from the top of the basket as well. You cannot reach anything below it if there is an item on top. You have to remove everything on top in order to reach the one below. Right. So stack is only one way in and then one way out. And so you use this operation called push to push an element into a stack, and then you use a pop operation to pop it out. So this is every language has this stack data structure, and then have those push and pop operation, right? And stack is known as the one on the bottom is the first in, right? The first you put it in, then if you want to get it out, you have to get all the other elements on top to get it out. So it's first element in will be the last element to get out. So it's the first in, last out, or last in, first out. So either call it FILO or LIFO, right? Last in, first out, or first in, last out. And in C++ implementation is using the standard template std : stack as the stack. So you do the header include stack, and then you declare the stack, and then this angle bracket with the data type that you want to store, a stack angle bracket, the type, whether it's int or double or float or string, what have you, right? The data type, and then the stack name, the variable name. Then you can call those method, those function pop, push, and then check whether this stack is empty, and then number of element using size. And then the top is the one that get the element at the top. So pop operation, you just remove the element. It doesn't return anything, right? So you have to be careful when you want to get the element at the top, but also remove it. Then you call this top function, get the value for the element at the top, and then call this a pop to remove it from the stack. Okay. So top and pop, if you need to save that value, you need to use pop before you call the pop. Once you call the pop, then it's gone. Right? And when you add an element, you push and then take the elements, the value inside parameter as a push. So both pop and top doesn't take any argument. Empty, checking empty doesn't take argument. Size doesn't take any argument either. So let's look at some actual code. Right. So this you before this, right, outside this main, you have to include stack. After you include it, Then you do this std::, stack, then the data type, and the name of the stack, stack1. Then you use a push function to push each element into the stack. So do 1, 2, 5. So I have 5 elements in this stack1. Then when you check the size of the stack, this will give you the size of the stack. This is we start from here, then empty will push 5 elements. This is return 5, right? And you use this to check whether it's empty. If it's not empty, so this exclamation is a not, all right? Not empty, we do this while loop. We get the element at the top, this will get the value, the top, and remove that element using pop. So what's the output of this while loop? Is it 1, 2, 3, 4, 5? Or the other way, 5, 4, 3, 2, 1? Remember, the stack is first in, last out, right? So which element is the last in will be first out. So 5 is the last in, so 5 will be first out. So the output of this stack 1 equal to should be 5, 4, 3, 2, 1. Okay, how about Q? So Q is different, very different from stack. Instead of just one way in, one way out, this is you can push from the end, and then you can pop from the head. Right? You have a head and a tail, or front or back. Right? So you can do the push. Will push from the back, and then you do a pop, will get the element from the front. So instead of like the stack called the top, then you will call this function front. So front will get the first element at the front of the queue, and you can continue to do the pop and push, right? Pop will remove the element from the front, and then push, add an element to the back. So this is fivefold the order, right? First in will be first out. So this is a typical waiting in a line order situation, right? When you go to anything that you need to wait in line, that's a typical queue structure. Right? And so you have a push and pop, and okay, so we need to modify this. This is another pop. So instead of the top, like the stack, so this will for front. Okay. And then has a front and back. So you can also get an element from the back. Okay, let's look at some code. Right. So we use std::q, right? Again, if you're using namespace std, you can remove this std::, prefix. It's just a different coding style for those STD data type, probably even though you're using namespace STD, still keep this STDQ so that you will never get into a name conflict situation, right? If you later on you forgot you name a variable as a Q, right? If you just call this a Q, then if you define this a variable Q without this one, and then you use the Q define another, then that will be an error. Right? But say you have this STD colon colon, you should never redefine that STD colon colon Q, right? Okay, so similar to the stack situation, you define this Q, then you push each element, and you can check the size, and then you can check whether it's empty, and then get the first element. Instead of using top, you're using front. And it's a front function. Get the first element at the beginning of the queue, and then you use pop to remove the element at the front, and finish it, right? So if we push this 1, 2, 3, 4, 5, then the output of this should be the same order as we push it in. So we get 1, 2, 3, 4, 5 as well, right? Unlike the stack situation, you push this 1, 2, 3, 4, 5. When your output is 5, 4, 3, 2, 1, that's in the reverse order. Versus Q, however you push it in, and then you print out exactly the same sequence. Okay, any question on the stack and queue? So there, go look at C++ reference or W3 school. Look at those functions that associate with the stack and queue. But just like the one that we show, so those are the functions that you should be familiar with. Then there may be other functions, but typically just use top and push empty size and then get the first element using top, or for the queue situation using the front. Okay. String, right? So in C++, there are two ways to define a string. Okay, there is continue to backwards support the C-style string. You using character, which is defined for each character, and then you're using this bracket, right? Bracket indicate this is an array of a character, then you assign the value, or you assign this using the braces as initialize each character. By each character, you put it into a single quote or double quote. Or you can also using this asterisk. This is an array of character. So this is a more C-style definition. So probably in USACO competition, we don't have to do this C-style string. Right? In some rare situation, this is C-style string just more memory efficient, right? But for our competition, you barely see any difference. So we don't really care. And in this competition, we don't need to use it. Just use a C++ string data type is so much easier, right? So just using string data type and define that you can initialize using parentheses, or you can use just a double quote. Okay? Okay, talk about this two type that's be aware that maybe if you're reading someone's code, even though it's C++, they may have some C style string in the code, so you can understand you. But for you to write a code, you don't need to write a code using C style string. Okay, so you just need to include the header string and then either using std string or you can using namespace std, then you can remove this std colon and just using a string. So that's a more typical when the string is just everywhere, right? You don't have to use the std colon prefix. And in itself, right, string is a variable length of a character, so it is a dynamic array. So when you define it, you don't really need to count how many characters in the string. And then when you define a variable, and later on, if you need to have a longer length of a character in your string, you don't need to worry about that, whether I need to allocate more memory or not, right? Or C++ handle that for you. So it's dynamically allocate how much memory you need. And when later on, if you grow the string longer, it will allocate the memory for you. You will never get the out of bounds situation. And then there is some way to initialize, right? You can copy a string, right, using parentheses to do initialize, or you can equal, or you can just using some constant value, put in a parenthesis of the value. So remember, when it's using parentheses, for those of you in the summer class, we talk about the class, right? And class was called a constructor, right? This is essentially a string constructor. When you put in the parentheses, it initialize this called a constructor. This is the initial value. So that's why what this parenthesis does is calling the constructor. This is assignment. So this is calling the constructor is more efficient. So if you want to have a tiny bit of efficiency, define the string using the parentheses, assign the initial value rather than using this assignment. Yeah. And you can also call this initialize another constructor, take two arguments. The first argument is the number of elements, and then this is the character you need to initialize. So this n, it could be the number, just take n copy of C, assign that to this S4. So use either this or this, right? So if you, for example, you want to initialize everything into blank, right? You can just quote a blank and then how many value you want to initialize to be blank. And then the string operations, so you can using the C out and then the C in, those are reading standard input and standard output, right? Put that into a string. Or you can use a file string, right? The one we see using the F in or F out that define the string. Or you can have other what called a string, a stream, right? Define that as well. And you can use this get line function, right? Read a line. If it has a multiple line, it can break that string has a line break. Then you can read one line at a time. And you can also using other function to check whether it's empty or side. So that's what's nice about using this C++ string. You have those built-in function. But if you use the C style string, then you cannot call this type of function. And then a general dynamic array in C++ is this STD vector. Okay. STD vector. I pull. This vector. So those are not the method. So the method associated with a vector. Right. First, you include this vector, and you either do using std : vector, or you can use using namespace std if you want to remove the std : prefix. Right. Recommend to keep those prefix std : to make it more readable, indicate that this is from the standard template vector. And initialize the vector, right? So you can do parentheses. This is a copy another vector into this constructor, right? Remember, parentheses is a constructor, right? Or you can you don't need to fill, right? It has this constructor. You fill the number of elements with this value, so you don't have to call the fill function for vector. You just call this directly the constructor, or just if you just have one value, then you assign this, or if it has multiple elements, you can use this braces. So braces is getting this as an array of elements and then assign to that. So this is different from that parenthesis. Parenthesis is a constructor versus this is using an array of elements. Or you can do the assignment. This will be equivalent. Okay. So you use a push underscore back to add an element, push an element to a vector. So instead of push, you're just using pushback. Right. So I wish they had been consistent, just use a push function. Don't use this push underscore back, but unfortunately, call this a push underscore back rather than there is no push for a vector. So use a pushback, and then you do have empty or side, similar to the stack and fill, right? You can check the empty or side. Empty or side, I think they are consistent functions for any data structure defined from the standard template. And so this is a constructor assign the number of element to this value, right? If it is an integer, or you can do that on the string as well. You say high exclamation. So this will make 10 copy of this string assigned to this vector. Right. And for any of those standard template data structure, you can use this range-based for loop, right? For each element in whatever that data structure is, right? Then you just using colon. So this range-based for loop, you don't have to use those typical, like for I equal to 0, I less than n, and then you increment I. Those are more traditional way to loop through each array, right? But if you don't know the type, or you can use auto, right? You just auto, it automatically calculate the elements type for you. So it's really nice using this range based. You use auto. This each element, whatever that sequence, whether it is a stack or queue or STD array or the vector, you can use the right. Just get each element of that sequence, then output that element. And so the last topic before I go to some example, I'm going to show you some all of those data structures. So the last concept it's called a function overloading in C++. Right? What's overloading is that you can define the same function with exactly the same name multiple times, right? As long as the argument, either number argument or one of the argument is or one of the argument has a different data type, right? As long as they are not exactly identical. Thus, the function name itself is the same name, but either the number of arguments are different or the argument type is different. Right? That's called overload. So good. Your example, why do we need this function overload? Okay, so before that, let's I have this thing array, the show. Right. So in function overload, yeah, here. Like earlier, well, without function overload, right? I define different type of function. Say whether the array is an integer, I define one function that will deal with the integer array. Versus if it's a double array, then we define a separate function. So this is not overloading, right? The function name is different, right? So what is overload is we call this the same name, right, which is in this situation, say print vector, then another print vector. So this is a print vector of integer type. So this vector, it is an integer type. Versus I can have this print vector, but it's handle the double type. So then same function, I don't care whether this vector is integer or double. I can call it just with this same function. And then it will at runtime, it automatically determine this vector path. It is a integer vector or this a double vector, then you will use. The inside this, they are identical because we use this auto for each element. We don't really care whether it is an integer or a double. So they automatically determine the data type. We just print this element. Okay. Or to say an overload, another type is this print vector can handle vector string as well, right? So each element, again, we use auto, right? So it can handle the string. So we overload this print vector 3 times. One handle integer, one handle double, one handle string. So when you call like build initialize integer vector, you push it 3 times, and then you can call using this print vector function, so that check each of the element in the output each element in this vector, right? And this is another one. Instead of push to initialize the value, this is initialize 10 element into -1, and we print this vector, see whether this is the case or not. And for this is a string vector. So we print push first, second, and third, then we print as a vector. And this is an initialized second vector with another vector to copy the element. So this I vector, this is defined here, 10 element -1, right? So you can use this constructor to copy another one, or you can use assignment to copy. And can use this 5 element and this 10 element of a string, right? Or you can give a list of element, assign the value, and or just directly after this value print, or call the constructor multiple element, right? So just remember, this is not assign 5 and 12 into this vector, rather than this is 5 elements of 12, right? So we assign 12 to this vector 5 times. And so this is a situation that you uninitialize, and then if you print, you would expect this to be an empty vector, right? So this is see whether this print vector can handle an empty vector situation as well. And then you can use a loop to build this vector and then print it. And instead of using this auto, using the range loop, which is much easier than those I increments, all right? So this is getting each element rather than using the index. Okay, this is using the index. So if we compile this code, we already compiled this already. Right? And we actually, oh, not other, uh, then we execute this binary. They can handle the integer situation, and then this assign integer to 10 times and string. So all of those output rather than using the for loop, so you can just overload this print vector function, right? So you can handle all kind of vector. So in the earlier array situation, we can create a print array and then overload. So we can call the, just say I want to break this. So just say print array, and we can copy the one that say double. Also, it's called print array, right? And there's, I don't have a print string, right? We can have another one say print string array. Then once you have this, right, overload this print array, then when in the core, then we don't need to have this print integer, and just a print array, whether it's n double, we don't really care. Then you can overload this function, right? So you can handle the situation, whatever it is, variable. Okay, let's leave a few examples. Let's see, let's compile this. Okay, 51. Okay, just a few need to have a column. Okay, so there is no error. We call that print array the overloaded function. It can print out whatever the array is. Right. You see, this function overload is just you define the function. So this, see the argument, this is a double array, this is an integer array, and then the rest they are identical. So which is okay as long as one of the argument is different, then it's treated as a different function, and then it will at the runtime it will find the right function to use. Okay, I think that's all for today. Let me just check this line. Yeah, so this is the overload function that we mentioned, print vector, and call this the overload function. Any question? Right. Next week, we will continue to study data structure. Probably, hopefully, though, we can cover the remaining data structure, including tuples, sets, maps, and binary tree, and maybe some graph. So all right. Thank you, everyone.